Hello everyone, my name is V and today I'm here to give you a tutorial about how to use Kafka methodology in inventory management. I believe that this video would be very useful for those who want to gain some new knowledge and techniques in determining optimum inventory level and help your company to reduce costs, maximize profit, and become more responsive to customer demand. So let's get started. These are a few points that I will cover in today's tutorial. First, I want to point out some weaknesses of EOQ and Pareto. These are two traditional methods or principles that is used by inventory manager in decide inventory frequency order or quantity order and safety stock. And secondly, I will give brief introduction about Kafka methodology. And then the third part, I will talk about how to generate a Kafka, and lastly, how Kafka can be interpreted and its practical application. So first, let's look at the limitations of EOQ. What is EOQ? EOQ is the optimum order quantity or optimum amount of goods to be ordered at one time, which can minimize the total cost of ordering and cost of holding. As we can see here, at this point, EOQ, the total cost is minimized. Total cost of inventory, carried cost, or holding cost, and changeover cost or ordering cost. Inventory cost can be the storage cost like renting, heating, lighting, staff, or capital costs such as loans, equipments, and ordering costs can be costs that related to placing an order like labor cost, documentation, inspection, cost of transporting, and so on. And this is the formula to calculate EOQ. We have to know demand quantity. We have to know the cost of ordering and cost of holding. Holding cost will be calculated by unit cost multiplied for inventory holding rate. So as you can see from the formula, the limit of EOQ is it's relying on the cost of ordering and cost of holding inventory. These costs are very difficult to calculate accurately in the real life. According to one finance manager, he estimated that the cost of ordering can range from £1 to £100, depend on what resources you wish to consider as a part of ordering. And the calculation of EOQ based on number of assumptions, which is not practical. Like constant demand, concern of unit cost, or constant lead time. For example, demand can change due to number of factors like economic fluctuations or seasonal demand. Unit cost can be changed by special offer or discount. And also supplier can be always on time on delivery to us. Another point is the formula only applies for one product business, so it does not allow the combination of different items in one calculation. So for each type of products, you have to calculate and track separately. So let's move on limitations of Pareto. What is Pareto or ABC analysis? ABC analysis is a common classification technique based on the rule 80-20. So items or inventory would be divided into three groups based on their rank of annual usage value or spending value. So you can see here, A class is the top 20% of items which have high value, accounting for 80% of spending value. And B class, the next 30% of items with value accounting for another 15% of total spending. It can be also 40%. A and B would account for 90% of total spending, and C class is the remaining 50% of item account for 5% of total spending. The advantage of ABC analysis is dealing with groups of inventory and help us to identify which one is financially important to us, and from then we can have the right position in managing each group. For example, we can allocate more budget to stock or order more frequently for critical items. So Pareto also have limitations. For example, it is not practical and detailed enough to just only divide inventory into 3 groups. What if business want to classify inventory into more groups? For example, a big retailer want to classify their thousands of SKUs into more groups, say 6 or 7. The second point is the fundamental principle of Pareto is closely manage the few important and infrequently replenish those with low value. This might lead to unconnected decision, although it is correct. For example, in some cases, some item might have low value, but it might be in high demand. And if it's classified in C class, then there might be risk of frequent out of stocks. For example, screw is very important to manufacturing, but it's cheap and it might be classified into C class. And if there's a stock out of screw, there might be manufacturing disruption. Items are classified based on financial value, regardless of the factors such as demand fluctuations or lead time. And Pareto predetermined percentage into each class regardless of what's appropriate for each item. So what is the justification for the rate 80-20 or 95-5? Why not 70 or 30? And what is the boundary between the two classes like A and B, B and C? And also like EOQ, Pareto based on assumptions of constant demand over 12 months. This is not practical because for some item, it might be seasonal demanded, and for the same item, for the same product, it might be classified in different classes in different quarter of the years. So the shortage of these traditional approaches in inventory management like EOQ and Pareto encourage more research comes in place to provide solution to overcome the shortcomings. That is how K-curve methodology has been around and developed since 1990. It was developed by a PhD with a planning staff at IBM manufacturing plant, first to resolve the question of what does it cost to place an order, because it's very hard to calculate it in reality, so they consider this factor to multiply ordering cost divided inventory cost in the EOQ formula as a constant K ranked between 1 and 100, and then it was further developed to examine the optimum number of classes and the effect of different data sets, and also more sophisticated approaches to determine the cycle stock. And it is still used by IBM consultants for their clients today for effective inventory planning process. So the next 2 parts I focus on K-curve. Firstly, I want to show you how to generate a K-curve. There are 3 stages. Stage 1, expressing an EOQ as an economic order period. Stage 2, building a bridge between Pareto and economic order period. And stage 3, the variation of K to react on exchange curve. I will go in detail in the next few slides. So stage 1, expressing the EOQ as an economic order period. So in this stage, we will use the formula and the calculations to convert EOQ into an economic order period in days. So I already put here all the formula, and I will go briefly to each one. So to calculate economic order quantity, we have very classical formula here. The square root of 2 multiplied to demand quantity multiplied cost of ordering or setup cost, and then divide to holding cost, which can be calculated by unit cost multiply inventory holding rate. But in K-curve methodology, they will replace the 2 multiplied C divided by I as a common factor called K. And when we replace this K into the formula 1, we'll come up with a simplified EOQ formula. The next step is to convert EOQ to EOP. So by dividing EOQ to demand quantity, which will give 0.02 years. So every 0.02 years, we have to order 20 economic order quantity, 20 units. And if we replace the K factor in this formula, this is EOQ, and we apply K factor here, it will come to this simplified formula. But it's still in 0.02 years. If we express D multiply B, actually demand quantity multiply unit cost, that is annual demand. To this formula, we will come up with this formula. But this time we will express the years by working days. Typically, we use 250 working days a year based on 5 working days a week. And we come up with the formula, with this formula. So when we have economic order period, we can easily calculate the average inventory by 0.5. That means inventory is like, average inventory is like half of the lowest inventory and highest inventory level. It's multiply for economic order period, and then multiply for spending per day. So annual spend divided to working days. And then we can come up with number of deliveries or number of orders. So we will divide working days by 5, that is economic order period. So if economic order period 5 days, every 5 days we will order, then in a year we will order 50 times. Now I will show you how to do it in Excel. So here I have the list of 200 parts with the detail of annual usage or demand cost per part, and then I have the constant K 30, working day 250. So this is the formula represent for K. And here in stage 1, we have to calculate EOQ and EOP in days. So here I already calculate the annual spend value, which is useful to calculate the EOP later. So I put here annual spend value. So to calculate annual spend value, it's easy. You just need to multiply the annual usage to cost per part, and then you copy the formula for the whole list. And to calculate EOQ, as you can see here, using K factor with a simplified EOQ, here I put here the formula, and you can put it with Excel formula here. So square root of K multiply demand divided by unit cost. So the same thing, you have to copy the list here and copy the formula for the 200 parts. So the next step is converting EOQ to EOP in days. As I explained to you earlier, this is the formula that we use to calculate the EOP in days. So I put the formula here and I generate in the Excel formula. Okay, working days 250 multiplied square root of K 30, and then divided to annual spending. Annual spending I have already calculated here, so I just put the formula here. And again, the same thing, I copy the formula to all of the items. So one of the interesting things that you can see here is when the annual spend value increase, then EOP, economic order period, decrease. For example, it's increased from 0 to 200. Then EOP decreased from this 32,000 to 94. And here, annual spend value is increased from 210 to 54. And then EOP, it decreased from 94 to 5. So what about EOQ? EOQ, it just developed randomly. It doesn't develop in any direction which related to annual spend value or EOP. So there must be some relationship between annual spend value and EOP, which is reverse direction. So there must be mechanism that can link these two values together. So this is stage 1. So let's move on stage 2, which is building a bridge between Pareto and economic order period. So in stage 2, similar to Pareto, but instead of classified item into 3 groups, now we will use a table class value for EOP based on the class limit or midpoint class boundary of annual demand. So how do we come up with the table? Here we use the value class from 1 to 9, and then the cycle days. The cycle day actually is the we just round up the economic order period. If you can see here, it's not practical to keep the order periods like 94.32 or 5.84, because in practice there's no supplier can deliver that level of accuracy to your order. So we just round up the cycle days: 5, 10, 20, 40, 80, and 160. Class limit. How come we come up with class limit? By putting annual spend value and EOP on a log-log scale with the simplifying of logarithm, they come up with this formula, and then I put this here to calculate the class limit. The class limit is the most economical point to switch from class 1 with 5 cycle days to class 2 with 10 cycle days. So based on the annual spend value, we can see, for example, if the annual value of the item between 9,375 and 37,500, then it can be classified at class 2. For example, here 10,924, it's between this one, so it will be classified at 2. So now we will classify all the items based on their annual spend value, and then choosing the cycle days to match the value class. So here I already put the formula to classify each item based on annual spend value. Here, then you can copy for all the item of the list, and the same with cycle days. The next step is to calculate number of orders. Number of order, we remember the formula here: number of order or number of deliveries. Working days divided to period of EOP, and average inventory, this formula. So here, as we already converted EOP to cycle days, so we will calculate number of orders based on the cycle days. Working days divided to cycle day, and then average inventory. Here's the formula. I'll just copy it, and we can come up with the total of number of deliveries and average inventory. The next stage is the we will vary the constant k from 1 to 100. Here I will take 1, 5, 10, 20, 40, 50, 60, 80, and 100, and I do the same calculation for each k value I put here. For example, it's 1, and you can see here the class limit is changed. So we calculate for the number of orders and average inventory, the total for all of the k value. And so after finishing calculating number of orders and average inventory, the total one of each value of k, we can come up with the table like this. And as you can see, when number of orders decrease, then average inventory increase. So at the opposite side, when we reduce average inventory, that we have to increase number of orders. And if we put all the data here onto a chart, scatter chart, we can generate a K-curve like this with number of orders and average inventories, and this is the value of K. So how do we can interpret the K-curve? When we look at the chart here, there is no cost of inventory or holding cost as they are replaced by K. And instead of consider which value of K we should use, we can come up with the question, how many of deliveries or number of order we can cope with. So this is easier to answer than what does it cost to place an order. So number of order here can be set as the capability of our company to receive the order. So when we know the number of orders, we can look at the K-curve and come up with the inventory level with fit our capability. So for example, if we talk to a warehouse manager and he confirmed that for now we are receiving around 5,300 orders, and with the K equal to 5. So we know when we look at the K-curve, we know that the inventory level at K5 probably would be around 38,500. So we can go back to the list and check the optimum. Another example is if our manager asks us to decrease the inventory level from 36,000 to 33,000, we can see here the order rate would be increased from 5,300 to 7,200. So in this case, we need to check with the warehouse supervisor if his department has the capability to receive 7,200, and if he confirmed that, okay, I would arrange new equipments or overtime for staff, then it would be okay. Then we just need to adjust the K. So why K-curve is so useful? It's useful because it shows the EOQ weakness. That is, it's creating mechanism for rational decision by replacing the constant factor K for 2 multiply C divided to I in EOQ formulas, as I mentioned before, as why C and I are very difficult to calculate. And instead of finding ordering costs and holding costs, we only need to determine the number of orders and the target inventory level based on the K-curve. It also shows the Pareto weaknesses with the value class table, allows more subdivisions and allocates the order side on the economic order principle rather than just allowing the lowest order side to the first 20%. So it said that it is more effective than the K-curve compared to Pareto exchange curve, as for the same number of orders, as much lower inventory can be achieved. So how K-curve can be used in inventory planning? By looking at the K-curve, we can establish a cost-benefit analysis for decision making. For example, we can know the cost of increasing the capabilities and the benefit of inventory reduction. As I mentioned, when you reduce the inventory level, you have to increase the number of order. The smaller the order quantity, the more often you have to order. So to increase the capability for the warehouse to process higher number of receipts, we have to increase labor costs like overtime or buying new equipment. So we can see if those costs will outweigh the benefit of reducing inventory before making decision. And the cost-benefit analysis can also be done at item levels. At TAFE analysis deliver the detailed information at part level, as you can see in the list. When the K change, the value class of that item also change, and hence the cycle days also change. For example, for some specific items which require specific handling machine, we can use the list to check the variation day in cycle days with different value of K, and then we can calculate the cost of upgrading the tools before making the decision. Yeah, and that's all for my tutorial. If you have any question, just feel free to drop here. Thank you for your listening.